Page number 90. Unit 2. The atmospheric pressure belts and winds. Unit structures. 2.0 Objectives. 2.1 Introduction. 2.2 Atmospheric pressure and wind belts. 2.3 Distribution of local winds, monsoon and planetary winds. 2.4 Variable winds and cyclones. 2.5 Conclusion. 2.6 Questions. 2.0 Objectives: to understand the nature of atmosphere, its structure and composition, to know the factors influencing pressure conditions and its impact on temperature conditions, to study the distribution of local winds, monsoon winds and planetary winds, to study the variable character of winds in different areas of the world. 2.1 Introduction. Atmospheric contains air. Air is a mixture of gases. Most of these gases have weight. Therefore, atmosphere has pressure. High pressure and low pressure belts are formed on the Earth due to isolation, rotation of the Earth, etc. Air always moves from the high pressure area to low pressure area. Hence, wind belts are formed in between pressure belts. Similarly, various types of wind systems are formed due to local variations in the atmospheric pressure. 2.2 Atmospheric pressure and wind belts. Air pressure. Air is a mixture of gases. Most of these gases have their own weight. Therefore, air exerts pressure on the Earth's surface. The weight of air on a unit area of the Earth is called air pressure. Air pressure at sea level is equal to 1013.2 mb millibar. Air pressure decreases with the increase in height or altitude from the sea level. Figure 2.1. Air pressure decreases with increase in altitude. Land. In sea level, density of air is more. Air pressure. Density of air is less in glass tube, vacuum, sound system, category. Atmospheric pressure. In this diagram, the weight of the air at sea level U is maximum. The weight of the air at B, C, D becomes less. Therefore, the air pressure at B, C, D and D will be less. D records lowest air pressure. Distribution of local winds, monsoon and planetary winds. 2.3 Distribution of local winds, monsoon and planetary winds. Pressure belts. Two types of pressure belts are found on the Earth. They are high pressure belts and low pressure belts. Before going into the details of these pressure belts, it is necessary to understand how these belts are formed. Temperature and atmospheric pressure are related to each other. There is an inverse relationship between the temperature and atmospheric pressure. Areas of high temperature are generally associated with the low pressure, and the areas of low temperature are associated with high pressure. In this diagram, place A receives oblique solar rays, therefore it records low temperature. Place B receives vertical solar rays, therefore it records high temperature. Figure 8.2. Due to high temperature, the Earth's surface at B will be heated more. The air near to this surface will become warm and expand, so its density will increase. Air of low density is lighter than the air of high density, hence the warm air being less dense will be lighter and will move in the upward direction. The upward moving air will displace upper air due to the gravitational atmosphere. As a result, the upper air will move towards nearby areas. That is A. In this example, now the accumulation of the Air is more at A, therefore the weight of air at A is more and hence A will be the area of high pressure and B will be the area of low pressure. Figure 2 points show solar radiation and temperature amount. On A, more temperature vertical rise or decreases. On B, slanting solar is less temperature. Thus, place A as high pressure and place B as low pressure. Air from place A will move towards the place B in order to maintain the balance in the pressure at A and B. Figure 2.3. This air which moves from high pressure area to the low pressure area is known as wind. Figure 2.3. Low and high pressure areas and wind. A. Atmospheric air pressure. H. Surface. B. Atmospheric air pressure. No. Ascending and descending air currents. Per wind. Air descent. Air current. Ascending air currents. On a global scale, air near the equatorial area is more heated due to more intense solar radiation. This air moves in the upward direction in the form of convectional currents. Therefore, low pressure area is formed at the equator, which is termed as doldrums. Air which is displaced by equatorial low pressure area descends down near 30 degree N north and 30 degree N south latitudes. Hence, pressure belts are formed at 30 degree north and 30 degree south latitudes. This pattern of alternate belts of low pressure and high pressure are found on the entire Earth. The major pressure and the wind belts are given in the following diagram 2.4. The first doldrums. It is the lowest pressure belt situated between 5 degree north and 5 degree south latitudes. Due to intense heating, low pressure area is developed. The air rises upward in the form of convectional air currents. This air is generally calm in this belt. Therefore, it is termed as doldrums, which means a belt of calm. Second, subtropical high pressure belt. This high pressure belt is found at 30 degree to 35 degree north and south of the equator. The upward moving air at the equatorial low pressure belt descends in these latitudes. Therefore, these become areas of high pressure. The descending air currents are found in this area of high pressure. This creates calm air without much movement of air. In olden times, sailors found it difficult to steer their ships due to lack of wind across these regions. In such situations, horses that were commonly carried as their cargo were thrown into the sea in order to conserve the food on the ship for survival of the sailors. Hence, these latitudes are also termed as horse latitudes. Air which moves from this high pressure area to the low equatorial low pressure area is termed as trade winds. Third, subpolar low pressure belt. These low pressure areas are situated between 60 degree to 65 degree north and south latitudes in both the hemispheres. The cold air at the poles is very heavy. Therefore, high pressure area is found at the poles. Descending air at the subtropical high pressure area is divided into two parts. One part moves towards the equator as trade winds, and while the other part moves towards the pole as westerlies. Due to the rotation of the earth, winds coming from poles, that is polar easterlies and westerlies, converge to 60 degree to 65 degree north and south latitudes forming subpolar low pressure belt. Fourth, polar high pressure belt ascending or the subpolar low pressure area descends down at the pole region, thus forms polar region high pressure belt. Shifting of pressure belts. The Earth's axis is tilted by 23.5 degrees to the vertical plane, so the Sun is stationary, but due to the tilting of its axis and revolution of the Earth around the Sun, it appears that the position of the Sun changes in different seasons or time of the year. This is termed as the apparent movement of the Sun. All pressure and wind belts shift to the north during summer in the northern hemisphere and to the south during the winter in the northern hemisphere or summer in the southern hemisphere. Hence, the shifting of pressure and wind belts is directly related to the apparent movement of the Sun. Due to the shifting of pressure on the wind belts, various natural regions experience different types of climatic conditions. Different seasons rainfall is most impacted by them. See figure 2.4 winds and pressure belts. At this, the equator east to southeast side trades and central Italy cell on the northeast and southeast of the equator. Feral cell distribution of atmospheric pressure. Distribution of atmospheric pressure is represented with the help of isobars. Isobar is an imaginary line drawn on the map which joins the places of equal atmospheric pressure. Spacing between the isobars helps us to understand the pressure gradient. Figure 2.5. A steep pressure gradient when spacing between isobars is less and isobars are close together. Hence, the wind speed will be higher. Generally, in the case of a cyclone, pressure gradient is very steep and wind speed is more. B. Gentle pressure gradient. In this case, the spacing between the isobars is less. Isobars are faster apart. Hence, wind speed will be lower. Generally, in the case of anticyclones, pressure gradient is very gentle as the wind speed is less. See, equal pressure gradient. There is no wind when the atmospheric pressure is same at two places. Figure 2.6. Figure 8.2.5 atmospheric pressure and wind speed. 1000 in wind breeze takes to Y990 1,100 EMP strong wind to Y850 1000 MBX 1000 current miss pressure no. Check your progress. 1. Define air pressure. 2. What causes the variation in atmospheric pressure? 2.4. Variable winds and cyclones. Winds. Distribution of the atmospheric pressure is uneven in the world. Winds are caused due to uneven distribution of pressure. Winds move parallel to the Earth's surface. Vertical movement of air is termed as air current. Factors affecting directions and speed of wind. Direction of wind means the direction from which wind blows. For example, easterly wind means wind coming from the east. Southwesterly wind means wind coming from the southwest direction. Various forces are responsible for determining the directions of winds. Some of them are as follows. Pressure gradient force, the rate of change of air pressure between two places is called pressure gradient. The direction of pressure gradient is at right angles to the isopods. Air wind moves from high pressure area to the low pressure area. The velocity or speed of wind depends on the pressure difference between the two places. Speed is more when pressure gradient is more or steep. Wind speed is less when the pressure gradient is less or gentle. Coriolis force, the force which deflects wind and is formed due to the rotation of the earth is termed as the Coriolis force after the name of French engineer Coriolis. Winds are displaced from the direction of wind gradient due to the Coriolis force. Ferrel formulated a law to indicate the actual direction of wind in the northern and southern hemispheres after considering the impact of Coriolis force. This law is known as Ferrel's law 2.7 figure. 2.7 Reflection of winds. I on southern hemisphere. Uh, Equator high pressure reduces to the equator, or northern hemisphere high pressure reduces to the equator. On the equator there is a low pressure. According to Ferrel's law, if we stand facing the direction which the wind is blowing, we will feel greater impact of the wind on our right hand side in the northern hemisphere and towards our left hand in the southern hemisphere. The effect of rotation on Earth on the direction of wind is minimum at the equator and is maximum at the poles. Classification of winds. Permanent winds. These winds have influence all over the world, hence they are also termed as planetary winds. Due to their regular nature, these winds are also known as prevailing winds. Trade winds. These winds blow from the subtropical high pressure belt 30° to 35° north and south latitudes to the equatorial low pressure area, that is doldrums 5° north and south of the equator. Characteristics of trade winds. These winds blow towards from the subtropical high pressure belts towards the equator. Trade winds are deflected to the right of their path in the northern hemisphere and to the left of their path in the southern hemisphere. They bring rain to the eastern margins of the continents but are unable to provide rain to the western margins of the continent, creating hot deserts on the western margins of the continent. Hence, these deserts are also termed as trade wind deserts. Trade winds are known for their steady direction and wind speed. Trade winds are replaced by the monsoon winds in the monsoon region. These winds are associated with cyclones and depressions. Westerlies. These winds blow from the subtropical high pressure belts 30° to 35° north and south to the subpolar pressure region 60° to 65° north and south. These are also termed as anti-trade winds as the direction is opposite to the direction of the trade winds. Characteristics of the westerlies. These are found in the temperature belt between 30° to 60° north and 30° to 60° south latitudes. Their direction is southwest in the northern hemisphere and northwest in the southern hemisphere. Since the expanse of the sea is very large in the southern hemisphere, the westerlies blow here uninterrupted. Hence, the direction of westerlies is constant and the speed is very high in the southern hemisphere. These are known by different names in different latitudes as given below. Latitude 40° south, westerlies known as roaring 40s, 50° south, furious 50s, 60° south, stormy or striking 60s. Western lights are associated with the changing nature and accompanying changing weather. The velocity of the western lights is more during winter as compared to the velocity during the summer. These winds cause rainfall almost throughout the year in western Europe, western Canada, and southwest Chile in the South America. Due to the shifting of pressure and the wind belts, western lights shift southward in the northern hemisphere during winter and provide rainfall to the Mediterranean region. These winds play an important role in the balance of heat at global level by carrying warm equal water and air to the temperate region. Polar winds. These winds blow from polar high pressure areas subpolar low pressure areas that is from 90 degree north south to 65 degree north south. Characteristics of polar winds. These are very cold and dry winds as they come from the cold polar region. Coriolis force is maximum near the poles, therefore the polar winds are more affected by this force. As a result, the direction is changed. These winds are experienced between the poles and subpolar low pressure belts. Polar winds are better developed in the southern hemisphere. Distribution of local winds, monsoon and planetary winds. Monsoon, seasonal winds. The word monsoon is derived from the Arabic word "mawsim", meaning season. These winds change their direction according to the season, that is, the direction of the winds in winter is opposite to that during summer season. Asia has the greatest monsoon influence as it is the largest continent. Here, India, Myanmar, Indonesia, China, and Japan experience monsoon. The other major regions of the world include parts of Australia, North America, South America, and the western coast of East Africa. Summer monsoon winds in the northern hemisphere during summer. The solar rays are vertical over the Tropic of Cancer, therefore the ocean and land mass is heated more. As a result, low pressure areas develop over the Central Asia in China and Peshawar in Pakistan. These low pressure areas are so strong that the air from southern subtropical high pressure belt reaches the equator as the southeast trade winds. After crossing the equator, these winds change direction due to rotation of the earth and become southwest monsoon winds. As these winds come from the sea, they carry moisture. Hence, they are able to give rainfall in India and other parts of Asia. Winter monsoon winds. The solar rays are vertical over the Tropic of Capricorn in winter season. As a result, low pressure area develops in Australia and high pressure area in Asia. Hence, the monsoon winds change their direction and become northeast monsoon winds. As these winds mainly come from land, they are not able to give rainfall to a large area. The Coromandel coast is Tamil Nadu gets some rainfall and northeastern monsoon winds. Figure 2.8. Figure 2.8 monsoon winds in summer and winter. On July equator on north side of the equator low pressure, southern side of the equator high pressure. On January north side of the equator high pressure and south side of the equator low pressure. Sea breeze. During daytime, land is heated faster than the water along the coastal areas. Shores near the land is also heated. As a result, it expands. The density of warm air becomes less than the surrounding polar air. Therefore, it moves in the upward direction. Hence, the low pressure area develops over the land. The air pressure is comparatively higher over the sea. As the winter water is relatively cooler, therefore the air from the sea moves towards the land as sea breeze during daytime. Land breeze. Water retains its heat for a longer period of time than land. Hence, the cooling process at the sea is very low. On the other hand, the land is cooled more quickly. Hence, the high pressure area develops over the land and low pressure area develops over the sea. Thus, the air from the land moves towards the sea and as land breezes during the night time. Figure 2 development stages of sea breeze. When sun is there, land is heated more. Air currents to the lower wind when at sea, sea breezes, ascending air currents on upper wind. Land and sea breezes have a moderating influence on the climate of the coastal areas. Hence, in this region, the range of temperature is less. Fishermen take advantage of these winds for going to the sea for fishing and returning to the shore. Figure 2.10 Development stages of land breeze. On the night, land breezes towards the sea. Local winds, planetary and permanent winds have their influence on the entire globe, but local winds have their influence only on smaller local areas over which they prevail. Therefore, these winds are termed as local winds. These are known as by different names in different regions. Some of the local winds are as follows: mountain and valley winds. These are found in the hilly regions. During the night, the air at the mountain tops becomes quite cool. Its density increases and it flows the slopes into the valley below during nighttime or early in the morning before sunrise. As these winds come from the mountains, these are termed as mountain winds. These are also known as cataptic winds. Figure 2.11 Mountain and Valley Winds. In the morning, sun heats wind valley winds warm. At the night, moon comes mountain winds cold. During the day, air at the bottom of the valley is heated due to the solar radiation. Its density becomes less. This light and warm air moves in upward direction along the hill slopes. As these winds come from the valley, these are termed as valley winds or cataptic winds. Chinook. Chinook means a snow eater. This local wind descends down the eastern slope of the Rockies mountain range in the western part of North America. As Chinook descends down from the eastern slope of the Rockies, it becomes warm. Ascending air along hill slopes becomes cool, while descending air becomes warm. Snow melts due to Chinook in winter, hence it is termed as snow eater or Chinook. It increases the temperature of the prairies and helps in farming activities in the region. Foehn: The winds which cross the Alps or descend down in Switzerland are called as Foehn or Foehn. Other similar winds which descend down the mountain slopes and increase the temperature are as follows: Nor'wester in New Zealand, Santa Ana in California, Samoon in Iran, Waves in South Africa. Other types of local winds are Sirocco, Hot Sahara, Solano, Hot South Wind, comes in hot and dry, Egypt, Shimon, Earth, and Rai, Arabia, Mistral, cold France, Flora, cold Adriatic coast of Yugoslavia. Checker progress. Different winds give you a classification of winds experienced land breeze and sea breeze draw diagram with what is to know. These winds are associated with a pressure system that is low pressure or high pressure. These winds do not blow in any particular direction regularly. Their origin and direction of movement depends upon the formation of pressure system. The major types of variable winds are cyclones and anticyclones. Cyclones are associated with the low pressure system. Cyclones which develop in the tropical belt are known as tropical cyclones, while the cyclones which are developed in the temperate belts are known as temperate cyclones. Tropical cyclones are more intense and more destructive than the temperature cyclones. The tropical cyclone is represented by concentric circles of isobars having low pressure area in the center. The pressure gradient is very steep, and so the isobars are very close to each other. Winds move towards the center, and the direction of wind is anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. Major characteristics of tropical cyclones. Tropical cyclones mostly develop over the sea's water bodies. Reservoirs are usually in the form of concentric circles. The pressure gradient is very steep. Wind speed is more than 100 km per hour. Tropical cyclones are small in size. These are associated with heavy rainfall. These cyclones occur mostly in summer. The cyclones travel from east to west. The center of the cyclone is known as hive of the cyclone. There is no movement of air, calm condition, and no rainfall at the center of the cyclone. Direction of wind is anti-clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. Tropical cyclones are known by the different names in different parts of the world. Example: typhoons in China, tornadoes in USA, cyclones in India, hurricanes in the Caribbean, and willies in Australia. Tornadoes. These are more intense tropical cyclones where the wind speed is between 300 to 500 kilometers per hour. These are mainly found on the Mississippi plains of the USA. They cover a very small area that is about 100 to 500 meters of diameter, funnel-shaped thick ground to sky. It appears dark as brick, sand, and other material on the earth is lifted in the funnel by the strong wind, hence it causes maximum destruction. 2.5 Conclusion. It is important to note that the differences in pressure caused by temperature differences due to variable factors give rise to the formation of different seasons throughout the year. When it is harvesting in northern hemisphere, the southern hemisphere undertakes the sowing of seeds. This seasonal difference provides us with food crop and other agricultural products throughout the year. 2.6 Questions. Define air 1. Define air pressure. Explain factors of determining atmospheric pressure conditions of the air on the earth. Write a detailed note on distribution of pressures. Draw a neat diagram. How do land and sea breeze influence the pressure condition? Write a note on mountain winds. How is a cyclone formed? Give different types of cyclone. Draw a neat diagram to represents Chinook wind. Explain the following: A. Doldrum. B. Farrell's law. C. Tornadoes. Strategy references 1. Petmakers Shindet Chapter 2015 Physical Geography FIB Semester 1 and 2nd Research Publishers Private Limited Mumbai 2. K. Siddhartha 2001 Atmosphere Weather and Climate Cause IA Application Private Limited in New Delhi 3. Surinder Singh for Geography Tata McGraw Hill Publication New Delhi, Sir A4 Savindra Singh 2001 Climatology Prayag Pustak Bhavan Lahore 5. Ajit PS call //www.google.co.in/search version 2 equal diagram plus for plus winds plus and plus pressure plus off plus volt and BIW equals 1366 and BIH equals 655 at dBm.